Put your name and the date at the top of the page. We are starting a new unit today. Our module is Module 3, and the first lesson is representing proportional relationships. This is pages 59 through 64 in your book. We have an essential question. How can you use tables, graphs, and equations to represent proportional situations? So we have a definition. Proportional relationship Proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. For instance, we could talk about miles to kilometers. This would be where we have 1 mile is equal to 0.6 kilometers. Another ratio for that would be 2 to 1.2, or 8 to 4.8. Those will all be constant. They will be the same value. Next, we have constant of proportionality. a number k in the equation y equals kx that represents the proportional relationship. This is our equation. The k represents this proportional relationship. Sometimes another way of seeing that would be that k equals y over x. We have a story problem for example 1. Megan earns $12 an hour at her job. What we want to do is show that the relationship between the amount earned and the number of hours worked is proportional. So I'm going to say show that the relationship is proportional. Then write the equation. For the relationship. What we need to do here is build a table to start with. And I'm at the bottom of my page, but I'm going to go ahead today and I'm going to build my table right here. Okay? We are comparing the number of hours worked to the money earned. Notice I'm using my line here. Usually you probably need to have about 4 values. We know if she works 1 hour, she earns $12. If she works 2 hours, she will earn 24, or 2 times 12. 4 hours is 48, and again, that's 4 times 12 there. And 8 hours is going to be 96, where this is 8 times 12. $12 being the amount that she earns for each hour. Now there's my table. It's kind of simple to remember. I'm going to turn my page to continue this example. After we build our table, then we need to build a ratio from that table. Now, the table's on my previous page, but I remember what it was. We need a ratio. And the important thing here is to label that ratio. What we're wanting to do is compare the amount earned to the number of hours worked. And if you'll remember, it said if she works 1 hour, excuse me, she earns $12. But we also extended that table, and for 2 hours she earned $24. 4 hours was 48, and 8 hours was 96. If you use your calculator, all of these reduce down to 12 over 1, or 12. So, therefore, the relationship is proportional. Now, I gave you a symbol here. The symbol, therefore, that's what it means. Now we also have to write our equation. If you go back to the definition, the generic equation was y equals kx. This is our k. This is our ratio. So it becomes y equals 12x. And that's our equation. There are some very good examples in your book. We need to look at a graph, so let's do an example with a graph. And this graph is actually on page 61. It is comparing the weight of an object on the moon and the weight of the object on Earth. And we need to write the equation for this. I'm going to attempt to sketch that graph. This is the Earth, weight. This is the moon, weight. So So there's our graph. Now, you need to be able to read your graph. This is how much it weighs on Earth. This is how much it weighs on the moon. So if a 6-pound object, or if an object on Earth weighs 6 pounds, on the moon it's going to weigh 1 pound. 12 is 2, 18 is 3, 30 would be 5. You can build a table from that information. We had something that weighed 6, 12, 18, and 30 pounds on Earth, and that was what it weighed on the moon. One thing I want you to realize about these tables that we're building is that this is generally our x value, or our x-axis. This is our y. So after we build our table, then we find K. And K is the moon to the earth. Remember, go back to that definition where I gave you the equation and I gave you that other version was y over x. That's why I put moon on top and earth on the bottom. So this becomes 1 over 6, 2 over 12, 3 over 18, 5 over 30. All of these reduce to 1/6. So that is our K. So our equation would be y equals kx, and we just found k to be 1/6. So there's our equation. Okay. Now, I have given you assignments in the past. Today is going to be different because we're actually flipped now. So you should have taken all of these notes at home. So now we're going to call this a quick check. And what this does is it checks to make sure that you did your homework, which was to take your notes, and in your book, because you should have taken these pages out. These are from the book pages. And it's your ticket into class, because I will ask to see your answers as you come into class. So, 1, you're going to look at your turn. Number 3 on page 60. Numbers 4 and 5 on page 61. But I also want you to go to page 62 and do numbers 1 through 6. These problems will practice what we've done in the notes. Look back at your notes as you do these. Do these on a sheet of paper or on these pages from the book, and have them ready to show me as you come into the classroom. Not after you get in the classroom, but as you come in. Good luck. See you tomorrow.